Hey and welcome. This is going to be a quick demo of Mirror-D. And for the purposes of this demo, we've set up a test cluster that you can see on the screen. The main service is the IP visit counter, which exposes a web-facing API and then counts the number of times each IP has accessed this API. Behind the scenes, it saves the IP to the Redis. It accesses another microservice in the cluster, and it sends a message to Kafka, and of course returns a response to the client that made the original request. So for this demo, I'm going to be using the Mirror-D plugin for Golang, the JetBrains Golang IDE. Mirror-D also has plugins for all the other JetBrains IDEs, as well as VS Code, and it can be run in the CLI. And the cluster we've seen before, it's running in the cloud. As you can see, it's running in GCP. And suppose I'm now developing the IP visit counter service. I'm writing a new feature for it or something, and I want to see how it behaves in the context of the greater application. But I don't want to set everything up locally, or maybe I even can't, and I have everything running in the cloud. So I'm going to be using Mirror-D to see how my local code behaves in the context of the cloud cluster. So when I install Mirror-D, it adds this button to the IDE, this enable disable Mirror-D button. And what this button does is when I enable Mirror-D, the next time I run code in my IDE, run or debug it, it's going to run in the context of a remote pod in the cluster. And it's important to note that the only prerequisites for Mirror-D to run is A, for the plugin to be installed, and B, kubectl access to the cluster. It uses only the Kubernetes API to operate, so you don't need to install anything in the cluster or something like that. So I'm going to enable Mirror-D and debug my code. And then I get this window, the target selection window, where I can select the pod or deployment in whose context my local code is going to run. So since I'm working on the IP visit counter, I'm going to select the pod running the IP visit counter in the cloud and wait for the local process to initialize. There we go. So let's start stepping through the code and understanding what we mean when we say that it's running in the context of the cluster. So the first thing my code does is call a function called load config. Let's step into that. And we can see that it reads a bunch of environment variables. So let's step through here. And we can see these variables have been populated with values from the cluster. Now let's step out of load config, and the next thing my local code tries to do is read a file. It tries to read it from a path at app-response.txt. This is the path that it got from an environment variable in the remote pod, and it doesn't exist on my local machine. But when my local code now tries to read the file, it succeeds because Mirror-D makes it read the file from the remote pod. So the next thing that my code is going to try to do is connect to Redis, the remote Redis, using a connection parameter that it read from the remote environment variables. So I'm going to continue execution here, and it connects successfully and to Kafka as well. And the reason this works is because Mirror-D also tunnels DNS resolution and outgoing traffic through the remote pod. So when my local code tries to resolve the Redis hostname, for example, it does so in the network context of the remote pod. And then when it sends an outgoing request, it does so through the network context of the remote pod as well. So things like Redis and Kafka are supported natively without any specific code, because for Mirror-D, it's all just network traffic. So now we'll just let it run. And it's now listening to incoming requests. Now, by default, when incoming traffic reaches the remote pod, Mirror-D mirrors this incoming traffic. So it duplicates it, sends a copy to the local process. Meanwhile, the remote pod has already answered this request. So let's see this in action. So I'll be sending a kernel request to the following domain. This is a regular domain on the internet. It's directed to our cluster, to the remote IP visit counter. Please don't DDoS it. And let's do this. First of all, we can see that we've already received a response. And we've reached get count, which is the function that handles incoming requests to the count path on our local code. So now we can step through the code, and this is our local code. So we can even make changes if we want, but you can just see how it behaves with incoming traffic from the remote pod. It accesses Redis with no problem. It does the same with Kafka. So that's it. So we've got incoming traffic from remote easily into our local code running in the IDE. Now, when mirroring traffic, when your local code sends a response, it's essentially discarded. It's the remote pod that answers the client's request. But what if we want to test out the response of our local code as well? What if we want the client to receive a response from our local code? So this is what MirrorD's steal mode is for. So to configure MirrorD to use steal mode, we'll use MirrorD's configuration file. You don't have to have a configuration file. If you don't, MirrorD just operates with the default configuration. But then if you want to start tweaking it, as in changing mirroring to stealing, then you need the configuration file. And so we'll go here to the MirrorD dropdown and click settings. Since the file doesn't exist, it's now created under .mirrord, JSON. It can also be YAML or TOML. And we'll just change this value under feature network incoming from mirror to steal. However, let's take this one step further. When I use steal, I steal all of the incoming traffic to the remote pod. So if, for example, I'm sharing the environment with other developers and they're working on a component that somehow interacts with the IP visit counter in this case, then I'm going to be affecting their work, which is why we added the HTTP filter feature. So to use it, we'll change the incoming key. We'll expand it here. We'll keep mode as steal, and then we'll add filter with this header. And now what's going to happen is only traffic, only HTTP requests with this header are going to reach my local code. Any other request is going to be handled by the remote pod. Okay, so I'm going to break execution on my currently running process. And before I demonstrate steal, I'm going to make a quick change to my local code. So I'm going to add some gibberish to the count key that's returned as a response to the request to the count endpoint. Now I'm going to debug the process again with MirrorD enabled. I'm going to select IP visit counter in the remote environment as my target. I'm going to wait for it to initialize. Here we go. Okay, so now it's up and running, listening to requests, and I'm going to go to terminal and send the original request first without any headers, and it returns immediately without the gibberish that I added to my local code. That's because it's returned from the remote pod, because it doesn't have the header that matches the filter that we specified. But now, if I send it with the header, so it hits a local breakpoint, and we can see that the request is blocking, of course, until I continue execution. So I'm going to do that. And yeah, the response was returned with the gibberish that we added locally. So my local code answers the request when the header matches the header filter. So just to summarize this bit, steal lets me completely intercept incoming traffic to the remote pod and then respond to it. So the traffic completely skips the remote pod. But then if I don't want all the traffic to be stolen, but only traffic matching a certain header, maybe because the scale of traffic reaching the remote pod is high, or maybe other developers are using that pod, I don't want to receive the response from my local code, then I can use the header filter. And then only requests with headers matching that filter will be stolen. Yeah, so this was a basic demo of MirrorD. Just to recap, we set up a staging environment, a remote environment for a pretend product with microservice architecture, and then we're able to develop one of the microservices against the staging environment from our IDE without affecting the staging environment and with access to remote microservices, databases, files, etc. So significantly cutting down our development cycles because we didn't have to go through CI, through deployment, making development a lot smoother and more enjoyable, I hope. So that's the demo. You can read more about MirrorD on the website, mirrord.dev. We have a Discord channel where we're always available. So hope to see you there. And I hope this was helpful.